we're going to look at identifying proportional relationships. And what does that really mean? So, if you remember back to all the other lessons we talked about proportional relationships, there's two things that have to happen. One, it's got to be a straight line. And two, it's got to pass through the origin, which is right where the x and y axis meet in the middle. So, when we look at word problems like this, we want to know whether or not they're proportional. And that means they go up at a constant rate no matter how many movies you get. Now, here's a typical club membership to like movies, or back when I was growing up, we had CD clubs, and you could get like 7 CDs for the price of one, and then you had to order like 6 additional CDs. Well, nowadays they're offering movie clubs, and so your initial value is you get 4 movies for the wonderful price of $1. But is that really a proportional relationship if each additional movie costs you $19.95? Now, if you don't buy these 4 movies, or if you don't buy the additional movies where you have to purchase 6 other movies, then what they do is they send you a bill on your credit card for $19.95 times 4. So if you don't purchase additional movies, they're going to charge you about $80 for those 4 movies. So it's really not that great of a deal if you don't buy the other movies, which is going to cost you about $120. So what we want to look at then is this proportional, which means no matter how many movies you get, it goes up at the same rate. So we'll create a little table. So we'll say M is for movie and P is for price. So to start with, you get 4 movies for $1. Then you get your next movie for $19.95. So if you add 1 to $19.95, at that point, you will now have paid $20.95. And then if you do another movie, you add $19.95 to that, which is another $20, which puts you at $40.95, but then you take 5 cents off, so you're at $40.90. So you're about $6 a movie. That's still a pretty good deal, but with all the streaming services, it might not be worth it, and so on and so forth. So it's just a consistent value. So basically, this is your X value, this is your Y value, and you want to find what is the K value for each of these. So that is 1 over 4 for this first one. This one is basically $20.95 over 5, which is about $4.19. So this was 0.25 cents a movie. Now it's at $4 a movie. The values aren't the same when you do Y over X, and therefore this is not proportional. So let's look at whether or not cleaning the floor is proportional. So here is a chart. Once again, when you talk about floor and time, usually when you have a chart like this, you can usually say the top one is X, the bottom one is Y. As long as you keep it consistent, it doesn't really matter. You can still tell whether it's proportional or not. And so what we want to do then basically is find the K value for each one of these. So the first one is 8 over 4, which gives you a K value of 2. The second one will be 14 over 7, which gives you a K value of 2. The next one is 20 over 10, which gives you a K value of 2. The last one is 26 over 13, which gives you a K value of 2. So if you look at all these, they all have a proportional constant of 2, 2, 2, and 2. Therefore, is the amount of floor that you can clean proportional? The answer would be yes, because all your K values are a value of 2. Next, is this person's savings proportional over time? So once again, we'll call this X, we'll call this Y. And so basically you're going to do Y over X and see if it's proportional. So K equals 1 over 40. The next one gives you 4 over 130. The next one gives you 8 over 250. And the last one gives you 12 over 370. Now, you can reduce this one a little bit, which then gives you basically 2 over 65, which if we compare that to 1/40, that is not the same. If we reduce this one, this is going to give us 4 over 125, and that's about as far as you can reduce it. So it's not equal to that. So none of these so far have been the same, therefore we don't have to do the last one, and therefore this is not proportional. So remember, to tell whether something's proportional, you always want to take your y value and divide it by x, just like we talked about many times before. And if the values are not the same for every single ordered pair, then it's not proportional. So here we have a table and we want to know whether it's proportional. So you have x and y. Now one thing that's missing on this that was a glitch is that these are actually fractions on top. So that is 5/6, that is 25 over 6, and that is 125 over 6. So there's a couple ways to look at this. One, you could actually just do the k values, which will give you 2 divided by 5/6, because 2 over 5/6 is basically the same as this. And so if you do your fraction math, that will give you 2 over 1 times 6 over 5. And if you multiply that, that gives you 12 over 5. So that's our first k value. Our next one then is 10 divided by 25 over 6. So if we write that out, that gives you 10 divided by 25 over 6. And if you review your fraction math, you turn this into a fraction, then you do the keep, change, flip. And so that gives you 10 over 1 times 6 over 25. All those fraction rules we learned all early on the year, it comes to help you out in all these other skills in math. And now we just can reduce. And so you can reduce the 10 and the 25 by 5. So if you reduce that by 5, you get a 2. If you reduce this by 5, you get a 5. When you multiply straight across, you get, once again, 12 over 5. And so far, the first two are proportional at 12/5. So let's do the last one. We have 50 over 125 over 6, which then gives you 50 divided by 125 over 6. Once again, we have fractions, so we can make that a fraction. And then once again, we do the keep, change, flip. So we keep the first fraction, change it to multiplication, and then flip the second fraction. And then we can reduce by 5. So that goes to 10, and that goes to 25. Then we can reduce again. That goes to 2, and this goes to 5. And when you multiply straight across, we get 12 over 5. And lo and behold, 12/5, 12/5, 12/5, they're all the same. And so going back up here, does the following table show a proportional relationship? Since every one of the k values is 12 over 5, yes, it is proportional. All right. We looked at one earlier with fractions. We'll look at one more. Once again, you have y and x values, and so we want to find the k of y over x to see if it's proportional. So that's going to give us 5 over 1/4. And so that gives us 5 divided by 1/4, which then gives us 5 times 4, which gives us 20. Because that's 4 over 1, which is just 4. Next up, we're going to have 10 over 1/2. That gives us 10 divided by 1/2, which then gives keep, change, flip, which gives you 10 times 2, which is also 20. So far it's proportional, but you always have to do the last one to make sure it's the same as well. So that gives us 15 divided by 3/4. That is 15 divided by 3/4. And then you do keep, change, flip. So that is 15 over 1 times 4 over 3. And so the 3 reduces with the 15, and you get 5 times 4, which is, once again, 20. So since they are all 20 as a proportional relationships of y over x, is the data from the table proportional? The answer is, once again, a resounding yes. And once again, here's another data table. We're comparing the age of a plant to the height in centimeters. Now these plants looks like they grow quite a bit. 120 centimeters is a 3-foot plus high plant. It's probably getting closer to about 4 feet or so. And so is this height proportional to the age of these plants? So once again, we'll call age on the top x, bottom one height y. And so is it proportional? Once again, we want to do y over x. And so if we take the y value of 12 divided by 6, that gives us 2. Y value of 70 over 14, and y value of 120 over 20. So the first one gives us 2. The last one here, if you divide that, the zeros cancel. 12 divided by 2 gives you 6. right there we could stop because the 2 does not equal the 6. And then this one here, there's not a lot to do there except reduce. And so if you reduce by 2, that goes to 7, that goes to 35. And then as we can see there, it's much easier to look at what 35 and 7 work with. 7 goes into 35 5 times. So 2 does not equal 5, and 2 and 5 both do not equal 6. And therefore, this is not proportional. So, in conclusion, if you want to see if something's proportional, whether it's on a data table or a graph, you always want to compare the y divided by the x value. How much does it go up versus how much it goes over? And when you do it for data tables, all 3 values, when you do the y divided by x, should be the same value. Here they're not. Here they were. If you have any questions, you know how to get a hold of me. Have a great day.